Hi everyone, this is Miss Wall. I've never done this before, so please bear with me on the quality of my first video for you. I just want to clear up anything that might be confusing on your homework tonight. This right here is number 9 on page 504. This is a system of two equations where we actually have two hyperbolas in this case, because if you'll notice, we have a positive in front of our x squared and a negative in front of our y squared, which if we were doing these separately, we'd go about seeing pretty easily that these would form hyperbolas. So when we're solving for a system, in particular with two hyperbolas, we're actually finding the intersection points of the two hyperbolas. So our first hyperbola might look like this, and our second hyperbola might look like this, and we're finding these intersection points. Not sure if it will actually look like that, but it's just a rough guess, just to give you an idea of what's going on. So this seems pretty confusing to solve for x or y right now, because we have lots of x squareds and y squareds and an x by itself, and what in the world's going on. So what I would recommend is to eliminate a variable that would allow you to have an equation with just x's or just y's. And it looks pretty simple that if we were to get rid of the y squareds, we would just have an equation with x's. So let's go ahead and do that. So to eliminate my y squareds, I'm going to go ahead and multiply this second equation by, let's do a -5, so we can add straight down. My new equation is now, if I distribute my -5 in, I have -15x squared plus 5y squared plus 30x equals -40. So that takes care of this second equation. It's the same thing, just with a new constant multiplied in. Now I'll go ahead and add these together. 3x squared plus -15x squared is going to give me -12x squared. -5y squared plus 5y squared gives me no y squareds. And then 0x plus 30x gives me 30x. 22 plus a -40 gives me -18. Hopefully now we can see pretty easily that we can go ahead and pull everything over to one side and factor this. So this has a GCF of -6. And I have 2x squared minus 5x minus 3 equals 0. Next I can factor to get 2x and x being factors of 2x squared. And I know that factors of -3 are -3 and 1. By a couple guess and checks, I can decide on x minus 3 and 2x plus 1. This leaves me with x being -1/2 or x being 3 for my solutions. Now that I have the potential x values in my solution set, I need to plug them into one of my original equations to find the y values for my solution set. I can pick either equation. It does not matter which one of the original two, because since these are intersection points, they should both come out with the same answer for the y's. So here we go. I just plugged in my x's here to the first equation, and I have 27 minus 5y squared equals 22. When I subtract 27 from both sides, I have negative 5y squared equals negative 5. Dividing both sides by negative 5, I have y squared equals 1, which means I need to take the positive and negative square root of both sides. Because if I were to plug in positive 1 for y right here, 1 squared would be 1 indeed, but also if I were to plug in negative 1 and square that, I would also get positive 1. So both of them work here, and I have y equals positive and negative 1 when x is 3. Next, I'm squaring negative 1/2, which leaves me with 1 over 4 minus 5y squared equals 22. So I'm left with 3/4 minus 5y squared equals 22, which gives me, when I subtract 3/4 from both sides, I'm going to get 21 1/4, which as an improper fraction is going to simplify to 85 over 4 when I subtract 3/4 from both sides. Then I can divide both sides by negative 5 or multiply by 1 over negative 5. And this leaves me with y squared equals, simplified, it would be negative 17 over 4. Now, the issue here is I'm going to have to take the square root of both sides, which will leave me with an imaginary solution, which is not possible in this case. So we can't graph it. It's not going to show up on our hyperbola. It's possible to have imaginary solutions, but it's not going to show up on our graphs. So there's no real solution here. When x is negative 1/2, there's no real solution. Therefore, our solution set is just x was 3 and y was 1, and x was also 3 again, y was negative 1. Hope that's helpful, guys. Have a great night.